Welcome to MrCScience.com's video on solutions and solubility. We're going to talk about solutions and how solutes and solvents interact with each other. In case you're unaware, a solvent is something that dissolves something else, usually a liquid, can also be a gas. A solute is the thing that is dissolved. It can be a solid, liquid, or gas. So in this module, we're going to look at solubilities of different phases of material and how they interact. Let's start with the most obvious one. Let's start with ionic compounds. Okay, let's take the ionic compound sodium chloride. Sodium chloride, as you know, is ionic because it's got a metal and a non-metal. It forms ions. Sodium a positive, it gives its electron to chlorine. Chlorine becomes a negative ion. Now this is one molecule of it. In reality, sodium chloride looks very different in the real world. So if we grab our molecule here and let's put it together here. So there's our, Control Z, let's just, okay, so there's again our molecule, but if we start adding molecules next to each other, they start interacting in such a way that the positive and the negatives come in closest contact with each other. So that positives will be surrounded by negatives, and what was that? And negatives will be surrounded by positives. There we go. Just like that. Put one more in there. So in reality, ionic compounds don't just form single molecules. They form crystalline structures usually. Structure here forms cubes. You can kind of see the cube between the negatives, or kind of a cubit between the positives. Sodium chloride. So it comes all together. So it isn't one atom of sodium with one atom of chlorine. So how does this dissolve? Well, if you remember from earlier in the chapter, water, which is bent, and oxygen being much more electronegative than hydrogen, the electrons in the hydrogen tend to spend more time around the oxygen than they do in the hydrogen. That gives it a positive. The hydrogen is a slightly positive charge and the oxygen a slightly negative charge. So that allows it, if we grab one of ours here, if we grab one and it comes along, now it's got to kind of get in between here. It will be attracted, so the positive charges will be attracted to the negative chlorine. But what happens is a water has to get in between to kind of force it apart. But if we could, here, let's ungroup that. If we could try one more time. There we go. So if the water can kind of get in between there, it can surround that negative with the positives on the hydrogen. Same thing can happen with the negative on the oxygen and the positive sodium ion. It can be surrounded by waters as well. And this allows the waters to kind of pull apart the solid and bring it into individual atoms or polyatomic ions, if we're dealing with something slightly different, to dissolve it, to pull it into solution. This is how ionic substances dissolve. Okay, so let's talk about polar covalent substances, solutes dissolving in solvents. Here we got a polar covalent substance called phosphorus trihydride, and if you remember, it forms a pyramidal shape with our extra 2 up here. The phosphorus is much more electronegative than the hydrogen, so Again, the electrons and the hydrogens tend to spend more time around the phosphorus than they do around the hydrogens. Again, hydrogen is the youngest child who always gets picked on and everyone steals his electrons. But so if we've got that and we've got a hydrogen here, let's grab a phosphorus or a phosphorus trihydride. If we put this up here, what's going to happen with the polar covalent water is it's going to, oops, the negatively charged oxygens are going to be attracted to the hydrogens, and the positively charged hydrogens are going to be attracted to the negatively charged phosphorus, and you're going to get, oops, I left a hydrogen behind. You're going to get dissolving this way. So polar covalent substances can dissolve in polar covalent solutes. So, or polar covalent solutes can dissolve in polar covalent solvents. So now water, a polar covalent substance, cannot dissolve non-polar covalent molecules, such as one reason oils like butter or just canola oil do not dissolve in water, because we don't have that attraction going on between them. So that will not work. Let's talk about phases. Okay, in solid phase, all the atoms are packed close together, tightly together. We could do the same thing with pH3. They would just be, the negatives would be close to the positives. It'd all be packed close together. So in solids, that polar covalent molecule, or whatever the solvent is, has to get in between the atoms or molecules in order to pull that apart. In liquids, molecules and atoms aren't quite as tightly held together. We're not talking aqueous here. You'd have to melt sodium chloride to get a liquid, in which case the atoms and molecules would flow easier between themselves. You think more liquids in polar covalent type substances than you actually do in ionic substances. Ionic substances tend to be solid, but with enough temperature you can melt anything. But polar covalence, in liquids the atoms are not held as tightly together, so it's easier for the solvent to get in between the atoms and help dissolve it. In gases, the molecules or atoms are spread very far apart, in which case the solvent has to be able to attract those, so it's actually harder to dissolve gases into a solvent like a liquid solvent like water, because the atoms and molecules have to get closer to it in order to dissolve. Two things that affect solubility of a solute in a solvent is temperature and pressure, and they behave differently depending on whether the solute is a solid, liquid, or a gas. If we look through here, solids. Now, as you increase temperature, what happens is you get more energy in them. In the molecules, they vibrate more. If you increase temperature of a solid far enough, it'll turn into a liquid because it gets more energy, and a liquid enough will turn into gas because it gets a lot of energy. So, remember, in a solid, we have to get that molecule, that solvent molecule, in between the atoms or molecules of the solid. So if we increase temperature, we increase vibrations, then it will be easier to get that solvent molecule in between the solid. With liquids, it turns out it really doesn't matter. They behave pretty much the same way no matter if it's cooler or hotter. So gases, Remember, in order to dissolve a gas, we have to get the gas molecule close to the solvent molecule. With gases, if they get a little more energy, they're moving more, it's harder to get them closer. So actually, as you increase the temp, it's harder to dissolve a gas in a solvent than it is. It gets easier in a liquid, harder in a gas, and really doesn't matter or easier in a solid, harder in a gas, doesn't matter in a liquid. Okay, pressure. Now, if you increase pressure on a solid or a liquid, doesn't really matter there either. Doesn't really make a difference. Where it does is if you increase pressure on a gas. Because you increase pressure, you are pushing things closer together, and increasing pressure on a gas makes it easier to dissolve that gas in a solvent. So hopefully that makes solutes and solvents a little easier to understand. Again, if you have any questions, feel free to contact me at mrc@mrcscience.com. Thanks.